Okay, good afternoon at this stage, everybody. You're very welcome to what is the fourth in our series of the MMC Ireland Lunch Learn. My name is Dick Clerkin. I'll be your moderator this afternoon. So I am the chairperson of the Education and Awareness Working Group at MMC Ireland and MD of Clerkin Consulting, a service provider to our clients across the built environment and the MMC sector. So speaking today on behalf of Amvic Ireland is Andrew Butler, Senior Technical Manager with Amvic. He's going to be going into detail of all of the great and good of ICF, one of the fastest growing MMC solutions in Ireland and beyond. So Andrew will be taking us into some deep technical information. It's not a sales presentation. You should be leaving here very well informed about ICF as a solution, its growth in Ireland, its core benefits, and some technical properties of it. So as I say, we purposely make sure that these presentations or lunch and learns are very informative. So you should be walking away having learned something about it. And it's not obviously, Andrew through Amvic are one of the leading providers across Ireland. I think it's a good story to tell. In the background, we have Anna Wadeen, head of membership of MMC Ireland. So if anyone's misbehaving, Anna will be coming after you. But all we ask of you is to just keep your microphones on mute. Conscious some people might have to take a call or a conversation in the background is fine. But we just want to try and let it flow because Andrew is a fair bit to get through. So what I'll ask you as well is if you have any questions, just drop them into the chat. I'll be keeping a track of them and then we'll put them to Andrew at the very end of the presentation. So I'm just going to hand it over to yourself, Andrew, and we look forward to listening to what you have to provide us this afternoon.
Great, thank you very much, Dick, and thanks for everyone for coming along. As Dick says, hopefully you get something out of today. So we're going to talk about, obviously, ICF. It's an MMC product. I suppose it's one of the MMC type of builds that has been around for quite some time. So I suppose everybody has a few challenges in the industry at the moment, whether it be availability of workforces, materials, whatever your place is in that journey, you have certain challenges. So I think ICF as a build method, the wall system can work very, very well to maybe solve some of those problems for you. Some of the headline things that I suppose what we're hitting with ICF, and certainly the feedback we get from the industry, is thermal bridging works well, how it's stacked up in embodied carbon, speed of build, inherent air tightness, which adds to other things, and I suppose hitting and exceeding our regulations where we need to. We also have different manufacturers, including ourselves, offering a full supply design and install package similar that you'd get with a timber frame. So certainly the ICF industry and the different manufacturers, I suppose, we've been working to work towards what's needed in the industry and facilitate that. So obviously just a little bit about ICF and what it is: insulated concrete formwork. So it's a single leaf construction. We're building the insulation and the structure all at once. As you can see from the image on the screen there, we have a concrete core, and inside and outside we've two EPS panels. It's an extra high density EPS. It's an EPS 150. Different thicknesses to different parts of the build, whether it be a party wall versus an external wall, and I'll show you a little bit of that as well. It's a molded polystyrene product connected by these webs. The webs are there for certain purposes, one of them being to carry reinforcement and fixings and various other things, and I'll show you a little bit about that as we go through. As I said, it's a molded product, so I just want to show you a little bit of the molding process and the manufacturing of the product itself. As I said, it's an EPS molded together into the machine, different types of materials, different types of uses. As I said, depending on whether it's an external wall versus a party wall, and I suppose every manufacturer helps you, I suppose, go towards what you need in terms of the product selection. As I said, it's been around for quite some time, as you can see from the timestamps there on the screen. Ourselves as Amvic, we've been manufacturing since 2005 in Ireland. In the early days, as you can see there, it was used in Europe. Early days of passive house construction, ICF would have been part of the feature builds back then. Moved towards Canada, the States, and as I said, came into here around 2005 into Ireland. So it's been around a long time, certainly a very, very tried and tested product. EPS in itself, that I suppose makes the ICF. It's a very, I suppose, good product in terms of its lifespan. It doesn't degrade over time, whether that's the physical capability or the thermal properties of the product itself. So it really stands the test of time. And obviously it, along with a concrete core, you have a really good build method there. Why did it grow? So maybe around 5 years, we were looking at maybe 3% of the market was where ICF was. Over the last 5 years, it's certainly taken, I suppose, a large part of the market for various reasons. I suppose labor issues is certainly one of the things, availability of the material on the ground. So that's, I suppose, one of the big benefits of ICF. Material on the ground can be delivered very, very quickly. So there isn't, I suppose, a huge lead-in period. Like everything, every product has its use. Every build method suits certain projects. But obviously, compared to, say, a panelized type of product or a modular product where you have a volumetric build or whatever, there's a lot more design process that goes into it. Whereas the ICF, I suppose, it's a lot quicker from that point of view and how we get it to site. So there's some of the reasons, I suppose, why it would have gained part of the market and how it has grown so well. As I mentioned, there are several types of blocks. Again, depending on what you're trying to achieve, whether it's compliant with regulations, compliant with passive requirements, we'll obviously help you select the product. I suppose one of the big things is really to be aware of is that, I suppose, product selection is there. Like whether it be a workshop, whether it be standard details, the manufacturer's there to help you and guide you. I suppose the big two differences in a lot of the blocks are the concrete core. So there's the image here that we're looking at, there's a 150 mil concrete core. So that's your typical external wall for, say, up to a 3-story build. When you're getting into a 4-story, 5-story, we're looking at a 200 concrete core. Again, with different thicknesses of insulation inside and outside to allow the requirements that we need to hit. Thermal performance, I mean, ICF stacks up very, very, very well. As I mentioned, it's made from expanded polystyrene. It doesn't degrade over time. It doesn't off gas. The cold bridging is eliminated very effectively with ICF. We can get very good U values. We can get very good psi values and the overall Y values. So just a snapshot of a typical ground floor to external wall junction. If we're building with ACDs, with a masonry construction, with a thermal block internally, we're probably going to hit an ACD value on a psi value of 0.07. With an ICF construction from rising walls up to the ground floor and continuing on up again with an ICF construction, we're probably going to see around psi value of 0.052. So when you're looking at how you build and how you get your A ratings and how your overall Y value works on your construction, using the thermal bridging, I suppose, that can be given along with the build really works well to get to the energy ratings that you need. So as I mentioned, we're the opposite, I suppose, to a cavity wall construction. So we're because it's a solid wall construction, because it's a single leaf wrapped in insulation, there's no air movement. So we're, I suppose, trying to get away from, I suppose, design versus the reality on site and what can be, I suppose, missed, little air gaps and things like that, I suppose, which in design, cavity wall construction can work well, but reality and I suppose the availability of block layers is becoming a bit of an issue. And we're hearing this more and more, speaking to, I suppose, other people in the industry as well, whether you're the developer or the architect or part of the design team. We're hearing this a lot more lately, I suppose, design versus reality on site. One of the big, I suppose, advantages is air tightness with ICF, is an inherent air tightness with the system and how it works. You're typically going to see an air tightness value with an ICF build around about the 1 air change per hour. To meet the regs, obviously we need to get 5 or less. I was doing a presentation with an engineering company recently, and one of the people there said, "Oh, funny enough, I just built an ICF, and we did a blower door test on the build. One of the windiest days of the year. The guy doing the blower door test was warning them, saying, 'Oh, we might get a great value here.' And even still, during a storm, they got a value. I think it was 1.5 air changes per hour. So we can hit the requirements. We can get passive requirements very, very well. So obviously that helps us in the energy performance, the thermal mass and how that works, the air tightness and the energy usage in the building. So if you're the person who's living in the house down the line, you're going to reap the rewards of that. Acoustic performance, obviously it's a big plus with an ICF build. So we've a reinforced concrete core there. A 150mm concrete core is going to easily comply with Part E, our acoustic requirements there. So we need to get 53 decibel rating or better. We're typically seeing around 56. Obviously, if we have a 200mm concrete core, we're getting a better value again. So just to kind of, I suppose what I want to do is kind of just show some typical parts of the build, the integrations of the different floors and some of the detailing. This is the snapshot, I suppose, of what ICF can do. So we're going to take it from the obviously the foundations. So ICF, you can use it whatever foundation type you have on site, whether that be a strip foundation like we have here. This one in the middle is ground beams on pile foundations. If you had an insulated foundation system, if you had a raft foundation, you can integrate an ICF from it. So a typical scenario, we come up off our strip, we would do our rising walls in an ICF block, maybe 2 blocks high, maybe about 800mm high. That's going to go in extremely fast. So 2 to 3 days, you're going to get your rising walls in and poured. Put in the ground floor. So the next part of the process is obviously we're putting in our fill, our radon, insulation, and slab. The radon comes up the ICF on the inside and comes across the external face of it. Any services, any integration of services, or I suppose penetrations that we need in the building, I suppose it's a big thing to get it in pre-pour. Very, very easy to do so. So you see the image on the right-hand side here, integration with services. Put in a sleeve, put in your services pre-pour, plan them out, get them located. Very easy to do and accommodate. When we're actually building, so then obviously the next lift then would be from our ground floor to first floor, and we'll always pour a floor at a time. So again, just some images from site here showing the action. When we're building, we'll have the scaffold around the outside, one side of a party wall, and then internally, then we have these push-pull props to align the obviously the walls during the pour process and during the building process. When it's being built, we don't pour the full height all at once. We will pour it in several hours, but it happens in basically 3 passes. So if you imagine, you can see they're pouring around the top of the walls here. They'll bring it up to maybe around windowsill level. Ensure that the poker vibrating is happening as it's being poured, bring it up to maybe window head level, and then top it off with the additional part of the pour. So it all happens really quickly, but I suppose it's in a controlled manner. So obviously it's a big part of the process that the people who are installing the ICF and managing it, that they're trained and registered installers with the manufacturer. I suppose big thing is quality controlling the concrete and I suppose working with the system. Typical concrete, 30 newtons, 120mm slump is what's normally used. To integrate with floor, so whatever, I suppose, floor type would be needed on the project, it can be integrated with an ICF very, very easily. So again, just to show you some images, we've posi-joist floors, we've precast floors going into different builds. So obviously, if we were doing apartment blocks, we'd probably have a lot of precast going on, concrete floors. If we're doing semi-Ds, 2 stories, we'll have posi-joist. Triplex, duplex units, we have a mix of both. So again, it can be integrated. If we're using a precast floor system, what will happen is the ICF will be poured up to the level of where the precast is going to be placed, so up to soffit level. The precast bears onto the concrete core, and then they'll continue the next pour out from there. If we're doing a posi-joist, what will happen is, if you see the little pocket in the ICF here, we take out a small pocket pre-pour. What the contractor will do is they'll put a small bit of plywood on the outside, let the concrete out to the face of the ICF. That gives us a fixing point to fix a ledger board and put in our top hung posi-joist. That fixing detail, that high load fixing detail, can be used for many other things as well. So there, I suppose, some typical floor finish. We see steel floors going into different builds as well. Internally then, the ICF would be used normally for your party walls. Internally then, for the standard, I suppose, partition walls, you can just use timber stud, metal stud as normal. Very simple to, I suppose, integrate into the ICF as well. In terms of finishing out and fixing materials and that kind of thing. So as I mentioned, the polypropylene webs that are molded into the ICF blocks, they serve a number of purposes. One is obviously to hold the panels in place during the concrete pour. The second would be to take the reinforcement. Normally you're seeing H12 bars at 1200 centers vertically and horizontally. And but it's also a fixing point internally for your plasterboard. So if you're doing chasing compared to, I suppose, block work, you're not having to stud it out. You're not having to actually chase the concrete or a block wall. All you need to do is basically use a hot knife, take a small sliver out of the EPS, place your conduit in there, get the electrician to mark out where they need it very, very quickly. And then we screw fix the plasterboard back to the ICF. And what we're doing is we're catching these webs. So you see the webs, they've a flat face to them. And there's a heavy line in the ICF to locate them, typically at 200 mil centers. So fitting out internally is very, very quickly. We've no air tightness membranes on the walls. Generally, the main air tightness is we tape around the window and door opes internally, and some of the builds they'll use an air tightness membrane at ceiling level, not even all of them. So very, very quick to finish off. Externally, the wall system is finished with a render system, so it needs to be a polymer modified base coat that's going onto the ICF. So that can be an acrylic or a silicon base. Needs to be an NSCI certified system, so that would cover a lot of systems. There's an incredible range out there at the moment, and it is built up in a couple of layers. I suppose like a standard render, you would build it up in several layers. When we put on the base coat, there would be typically a reinforcement mesh going in as part of that. Then obviously you have your primer, and then whatever color render finish you want to put on the outside. As I mentioned, these webs can be used for fixing. They can also be used for fixing externally as well. We see a huge amount of projects coming to build stage now with brick slip. We're involved in one at the minute, like 14,000 square meters of brick slip on 5 blocks of duplex units, and it's extremely, I suppose, good in how it compares to your standard brick. If you were to look at a build with a brick slip on it, it'd be very, very difficult to pick out any difference from a standard brick build. How that applies to the ICF, again, it's a very, very similar process to how the render system would go on. We start off with the base coat and then a mesh reinforcement within it. And then we change over to an adhesive, and then obviously the brick slip is adhered, wet to wet finish, and then grouted. What you'll find is generally with the systems, they're extremely high performing for weathering, for moisture, all that kind of thing. And the adhesive and the base coat will give an incredible amount of resistance. Essentially, the adhesive that I suppose you'd see in a swimming pool, so it can take a full immersion in water. So incredible systems. You still see some projects where they might want to use a full outer skin of masonry. That can be achieved also. And we can clad it externally with a timber or a zinc cladding. Obviously, we've details for all of these things outside of these images as well. If you're doing an outer masonry, you'd use basically an L-shaped tie, screw fix it back to your polypropylene webs, bed it into your block or your brick as you go. So all of that, whatever you're trying to achieve aesthetically with a design, it can be achieved with an ICF. And I suppose that's one of the big things that we see happening, is that people may have a design for a traditional, they can't maybe get a certain other, they might be looking at a timber frame, but the framers are at capacity, or they have a longer lead in time, and they'll come to say, right, we've designed and this is the finish we want. You can still achieve all that. I suppose that's one of the big things. Obviously, the top of the building, then we've our roof structure. So whatever roof structure you're trying to achieve on the building. So obviously, if it's a nice terrace and semi-Ds or a one-off house or something like that, we're going to have a lot of the time a timber truss roof. So this is a company called KPH in Cork. They actually put the trusses together on the ground and dropped them into position. Just a little efficiency. It's like everything, you're working with something for a long time, you create your own little efficiencies that work well for you. But obviously you can integrate with a flat roof. You can create parapets. You can put a concrete roof. We're doing apartment blocks at the moment. Concrete roof. You can do a green roof on it. So whatever the project intent is, again, it can be still all achieved with the ICF. To get into some, I suppose, the detailing, and again, there's only so much I can cover today, but I suppose give you some of the headline items, I suppose, things that we need to consider when we're moving over to ICF. How we close off the ICF. So as I said, it's the opposite to a cavity wall masonry construction. we have the concrete. So how do we stop the concrete coming out where we create the opes? So I suppose the traditional method would be to use a timber closer within the ICF like this. It's wrapped in a DPC, and as you can see, it's mechanically fixed in place during the concrete pour. The other method is a polystyrene closer. So it's essentially a slide-in closer that goes into the ICF. So that's the image on the left-hand side. So you see it in this door ope and this window ope. Same material as the molded ICF product. So, very resilient. It's going to last the lifetime of the building. And that works very, very well from a thermal bridging standpoint. So again, depending on what you're looking for in the project, if you're looking for those really low thermal bridging values, this is the way to go. I suppose the advantages, the timber, some people say, oh, well, it gives me a handier fixing point. And again, depending on the project, if you were, say, moving the windows further out with a flush window or something like that, that might be a benefit to you. Really, the only difference is with the slide-in closer, you're fixing a little bit longer back through the closer into the concrete core. But I suppose they're the two main closers that people would look at. This is becoming more popular. There is also profiled closers you can get as well. And again, we can advise and all that kind of stuff. I suppose one of the big things to be aware of, and funny, we had this conversation with a construction company yesterday. We brought them on site to see a build process. I said, right, the things that you need to get your head around, how does it differ to a cavity wall construction? So when we're dealing with a cavity wall, if we have moisture ingress, if there's a little bit of an air gap in the cavity, there's somewhere for the water to go, and there's moisture ingress in a cavity there, and it's dealt with. With an ICF, it's a single leaf construction. So how do we deal with it? Works very, very well, but it all comes down to the detail. And it's like everything, if you engage with the manufacturers ahead of time, we'll come to site, we'll do the workshops, we'll upskill the people. So we know those little intricate details, all the little differences with an ICF. So I suppose the big thing is around the windows and doors and how we prevent against moisture ingress there. So this is a typical window ope. We cut the window up, we create the pocket for the sill. So essentially what we need to do first with the sill is we wrap it in a DPC. So we create a DPC tray for that sill. So when that tray is sitting in here into that window, we've wrapped under, up the back, up the sides into those pockets. So you can integrate a concrete sill, metal sill, passive sill, reconstituted limestone, whatever you want to do. You can use the same sill. Probably most popular at the moment is the concrete, followed by the metal sills with the upstands on them. So number one, wrap the sill. Second point that we need to do then is the weathering around the window when it goes in. So when we connect the window and drop the window onto the sill, we have a good seal between it. When we're sealing around the jambs, so vertically around the window and door opes and across the heads, the first point of contact that we need to do, first step is a weather tight tape. So basically we're sticking a tape onto the ICF and returning it onto the frame. What you see in some of the more robust details is then, as you can see the detail here, we're then, as we bring in our render system, again, whether it's a brake slip or whatever it may be, we're integrating a solid, high density reveal insulation into there. So the tape is designed to take the adhesive of the render system. So when you return in your base coat in here, you can put on the render base coat here, that'll take that reveal insulation. So this is this image here in the middle. After that, then the next form of seal is the frame seal bead. So this is this little yellow strip that you see here that they're in the process of installing it. Around the sill, we've already brought in our weather tight tape here. We've then closed up the pocket then with an additional piece of EPS. We've put on our reveal, we've put on our frame seal bead. Under the NSCI certification, it clearly states we need two forms of seal. The most robust and resilient product that's going to be in there is that weather tight tape. Get that on and you'll have no problems. Get the reveal on, get the frame seal bead on. That's the way to do it. Do it right, do it once. And as I said, that little bit of a change as well as how that's done on site, once it's accepted, it flies along. Everyone gets on with it and it works really, really well. One of the other things is around service. So I showed you some of the pictures, I suppose, initially of how to integrate the services. Pre-pour, plan them out, get them in ahead of the pour. That's the way to do it. Again, detailing around ESB boxes and stuff like that. we've details around that. It's a similar way to how we deal with a window. That can all be integrated. And again, the ICF manufacturers will deal with that kind of thing. So just a snapshot of some of the projects, people that are using them. So a standard development enough there, relatively quick build, 10 weeks from the ICF standpoint to turn around the units, standard kind of render finish. This is just an image of, or a video, sorry, of a build in Tullamore. So that particular build, that was the customer's first venture into the world of ICF, went very, very well for them. So we're obviously seeing a lot of builds coming through now, and people trying it for the first time and having good positive experiences. So we're seeing a lot of brick slip, as I mentioned already. There's a 4-story build now. We're using the structure of the ICF to hang balcony structural elements there very, very well. We have a full wrap in the brick slip. We're seeing more and more nursing homes, primary care facilities, all that kind of stuff being considered with ICF, and the benefits to the operator, the owner of the build. Obviously, it can be a quick build, and I suppose that's one of the things that they find, obviously, when they move over to ICF is the build process. It comes together quite well, but it's the energy cost. So the air tightness and the thermal mass that comes with the ICF. It's a huge benefit, and the energy usage, because obviously in the likes of a nursing home, there's a lot more heat required. So the energy costs are dramatically low in comparison to, I suppose, normal bills. In terms of certification, so ourselves, Amvic, we have our NSCI cert and we have our BBA cert, obviously, and the other manufacturers would do as well. And I suppose where we stand at the moment in terms of build types and typology, we're certified up to 5 stories, typically 15 meters to your highest floor level. The BBA, that's just slightly higher at the moment. Looking at, I suppose, the future and what's coming down the line in terms of embodied carbon, I mean, something's going to come into regulation eventually, and I suppose looking at the embodied carbon and how ICF stacks up, and I suppose that would be a regular enough question. Ourselves, we have our environmental product declaration, so I suppose stating the embodied carbon of the product. And I suppose it's trying to tie it into, I suppose, how people are thinking and what people want from the manufacturers. Yeah, as I said, where the industry is going. So the RIAI have set their notional targets and where they want to be from a 2030 perspective. They have a target of 625 kgs of CO2 per square meter of build. I suppose we're trying to help people get towards that. As I said, we have the EPD and we have various studies showing on how ICF and it can stack up. You can throttle it to where you're upping the GGBS content within the cement to get very, very good figures or get similar to what's out there as well. So some interesting figures available. The last few slides, I suppose, another little bit of important detailing, a regular question. So the 2 typical questions we get is around detailing around sealing around opes and that kind of thing. The other one is fire complying with Part B of the regs and how that all stacks up for us. So the most popular way of fire stopping compartmentalization with ICF is a 1 millimeter metal strip. So we're showing in plan here a section where we have an external wall, we have a party wall coming in, where compartmentalization requirements at that point. So if we have, say, a 75 mil outer of ICF here, the metal strip is 85 mil, so it's 10 millimeters longer. So it's put in pre-pour, so you have an embedment into the concrete there, and it's catching there. So that's vertically, and we would use the same thing horizontally. So again, externally, say this is we've a precast floor here, and we compartmentalize outside. same thing. So that metal strip can be used externally, but it also can be used internally where we have, say, a concrete to concrete connection. So we have a concrete floor sitting onto an ICF build. Internally, we don't need to have any additional fire stopping. Where we have the posi joists, especially with a posi joist because it's an open web system, we use the metal strip. So you just see here, I have it circled. This is the metal strip running under the posi joist. Again, this is fitted pre-pour, 10 millimeters longer than the ICF is wider. And then obviously you pour the concrete, it embeds into the concrete itself. So basically you're trying to locate that metal strip at the ceiling board level. So you have a continuity there in your fire break. Fire testing, without being overly dramatic with a big picture of flames here, I suppose was just to give people confidence in how the render systems work, how EPS works, and how ICF works. So this is a fire test done by the Insulation Association back in March of 24, Jordanstown up north. 1,000 degrees, witnessed by Department of Housing. They came away very, very impressed with how the fire breaks work, how the EPS stood up, and how the render systems work. We have our own additional fire testing in-house as well that we did in the same facility with the metal fire break. Again, how that stacks up behind the plasterboard, how that works behind your render. And again, it's to give confidence to people that they can use ICF. And if you're dealing with a consultant on the project and they're looking for this information, that we have it available. And that's kind of a snapshot of where we are with the ICF. I've only one more slide after this one. So created from that, we have our fire guidance documents, but we have a huge amount of other things out there as well. Like ICF manufacturers, we can assist with your air tightness. We have guidance on that. Obviously, the thermal bridging, passive house requirements. If you're looking to aim towards passive house, how ICF can integrate, and the energy usage, thermal mass. Reach out to us. That's what we're here for. We're here to help. And the last bit is just, I suppose, a little bit of feedback from one of the projects that we're working on at the moment, just from, I suppose, one of the contractors.
The construction primarily is the main benefit. We're able to take the job from foundation level up to roof level in a very short space of time, which is great. Amvic have been great to deal with, from design right through to construction. They were able to show us how this is working out in other projects, how they're saving time, how they're saving money, and that's the main thing I would say is get out on the ground and walk the sites with the lads and see what they can offer. That would be my number one recommendation, to get out on the ground with the lads.
So that's a very quick turnaround project that we're working on at the moment. There's 95 units, I think it is, a mixture of duplex, triplex units, and it's come together very, very quickly. We had a 22-week build period for the 5 blocks on it, and it's come together very, very quickly. I suppose we brought another construction company to see the site recently, and what kind of stood out to them, obviously, you have a lot of advantages. Other things was, I suppose, how the ICF can work for the structural point of view, that we're not bringing in a huge amount of additional steel, that you could design additional reinforcement within the ICF structure. And we've beams sitting up high level, above balconies, carrying structure, all sorts of things going on. I suppose that's what kind of stands out to a lot of people when they see it, because it's I suppose the standard semi-diesel, very easy to accommodate in an ICF, but some of the intricate details that you see in the duplexes, the apartments, and all that kind of stuff, ICF can work for you on that as well. So there we go. That's my presentation as quick as I could.
Dick, you're on mute.
There you go. Thank you very much. Listen, thank you very much for that, Andrew. Very, very informative. Just while Andrew's catching his breath, so if you have any questions, can I ask you to drop them into the chat, and we'll have a quick read and filter off them and get them back to Andrew in a wee minute. So anything at all across, be it technical, around training, around compliance, whatever it might be, as I say, it's an open book here. Once we think it's appropriate, we'll ask the question. There's nothing overly commercially sensitive, I suppose. So give yourselves a minute there, throw it into the chat, and we'll drop it back to Andrew. A few here, I'll get the ball rolling with Andrew. It's sort of safe enough one around the training and I suppose the fitting of it. Obviously,
yes.
There's a couple of questions that come in around this, so I'll try and shape it into, paraphrase it into one. So,
sure.
Installation. the training off that? Who typically owns that? Is that a service contracted out? Is it the builder? Do you provide the training? How does that arrangement typically work?
So if I suppose there's a couple of scenarios that we'd look at there. As I mentioned, we have a full supply, design, and install package where a contractor comes to us, like that one in Dougal Brothers there, and we're doing the installation. We're taking on the structural design and handing them back basically a structure with a roof, with the floors on, all that kind of stuff. The other option is we have a network of installers, registered and approved installers, I suppose, are familiar with the system, have been working with it for many years, and have already gone through the training process with ourselves. And of course, different types of build types. So people that are kind of doing the one-off stuff to people that are doing the big developments that we see. So we've a network there. So if somebody wants to just purely engage with us, we can supply that labor element to put them in touch with the contractors. If we have a developer who has their own team or a builder who has their own team and they're looking to get upskilled, we have our own project manager full-time who would engage with them. We'll also provide the service where we can put somebody on site with them to train them and bring them, I suppose, on a training process through some of our own sites. And then obviously we have our classroom, if you want to call it that, part of it as well. So they'll engage with us initially, we'll do some site work with them, and then we'll manage them as they start to, I suppose, get up to speed on their own sites, and we'll oversee all that kind of thing as well, to the point where I suppose we're happy to let them off.
Okay, very good. Thanks for that. Another one here around capacity, Andrew. So without giving anything away, sensitive information. Obviously, there's a lot of headline numbers coming from government levels, politicians around the house that need to be built, 60,000, 50,000, 70. Pick your number. Capacity is the big question. Like, what do you see as the capacity for maybe the ICF industry in Ireland, and what are the constraints for increasing that in terms of capital plan for the installation or labour, or where do you see that in terms of your own strategy or that of ICF as an industry in itself?
Sure. So at the moment, as I mentioned, like the ICF is getting into the high teens in terms of its percentage of the new house built. Ourselves and I know other manufacturers, we have capacity there. From our own standpoint, we're probably getting on 60% capacity in terms of, I suppose, we've invested well into the machinery and what we have available to us, and having stock on the ground and the raw material and that kind of thing. So certainly from ourselves and I think the other manufacturers, we have capacity there that can supply the industry. I mean, ourselves alone, we probably did close to about 2,400 houses, I think it was, last year. So like we can get close to double that again, and go beyond that. And the other manufacturers wouldn't be far off that as well. There is plenty of capacity, and as I said, the big thing about the ICF is the availability of material. It's on the ground. It can be delivered within a week, which is a big thing. When it comes from the labour end of it, luckily we've been very, very good from that point of view in terms of, I suppose, the engagement and keeping the ICF contractors busy. And there's lots more people coming to us now from, I suppose, other trades as well, and say, well, I've been a chippy, I've been a block layer, I've seen how this is going. Can we get some training, and can we become installers? So you're seeing more and more people coming into it, and the good thing with the contractors, they seem to be readily available. So because I suppose the build of the ICF structure works so well, they can move on to projects quite quickly and I suppose keep up with the demand. So that's a really good thing.
Okay, sounds promising. Here's a bit of a niche question. I'll throw it out. So if there's an extension required, so obviously ICF still relatively new, there's new builds, but in time then there might be an extension. So how is there challenges around building an extension onto an ICF building? Does it obviously have to be done through ICF? How does it knit in? Is there any technical or build challenges around that?
There's not any huge issue from it. It can be done very, very similar to a standard, I suppose, how you connect up standard. We have details around connecting ICF to standard masonry, but it'd be essentially the same. So what would normally happen is you can dowel into, I suppose, create fixing points into the existing structure. So we can use chemical fixings. We can dowel into the concrete that's there and connect up the concrete of an ICF extension and the ICF itself. So we don't have to necessarily go back to concrete core for a standard kind of one-story extension going on to an existing ICF build. It's fairly simple. We're flashing in, we're creating, I suppose, the flashing and the ceiling details around it. But yeah, there's no issues there.
Okay, all right. That's all the nice, easy questions gone, Andrew. So,
right,
because listen, MMC Ireland, we're essentially agnostic. We represent all modern methods of construction, and everybody sort of makes similar claims in terms of pace, quality, energy values, etc. Where do you see is maybe some of the, not limitations, but every system would like to think they have a sweet spot in the market in terms of what types of builds really suit their product, and that they really have confidence that they can actually consistently deliver those. What do you sort of see that for ICF? Where is the main area of the market that you think that it is a good fit, and others that it gets a bit more complex and the cost benefits maybe get stretched a wee bit?
Sure. So I suppose the main limitation you have is around the story heights that you go to. So certified on the NSCI, we have 5 stories. Combining other build methods above that then becomes very, very tricky. So 5 stories is I suppose, the limiting factor with ICF. What we find is that timber frame works very, very well. Obviously, there's a longer lead in and design period that's involved in that, but works very, very well. They get the structure up quick. They can get it there sealed up very, very well. But I suppose they have a lot of follow-on trades in terms of the block work and that kind of thing. And we're getting good feedback on how this stacks up in terms of overall cost. So on projects, we can be very, very competitive with the other build methods as well. What we see some of the times is, say you have a site and somebody's looking at, they have a couple of duplex units down one end of the build and the rest are standard semi-Ds, and they might go with the timber frame on the standard semi-D types, and then the duplex units are the little bit more complicated. They'll use the ICF because maybe the timber frame isn't able to work in there, and they'll learn from that as well, see the advantages. Then it might flow out to, I suppose, following sites. So I suppose that's where we see kind of some of the wins coming from us at the moment.
Okay, very good. Bit of a technical question, and the sort of one that gets my interest. I'm originally a cement engineer. That's where I started out in Irish cement, so I'm always interested in cement and concrete and mixes.
Very good.
So the control of the quality of the board, because obviously it's not like block built that if you get a bad batch or the bricky sees bad blocks, you throw them out to the side and the pour starts. Sure. Invariably, it doesn't stop until it's filled. What are the quality control aspects around that? Because obviously it's massively critical to the overall build.
Yeah, absolutely. So I suppose one of the big things is I suppose the method and how the concrete is placed. So again, we would regularly get people coming to us. They want to build ICF, or can you supply us the blocks? We won't do it. They have to use one of the approved installers, because moving and using concrete and forming it is an art to itself. So controlling the pores, controlling the pressure on the material, controlling the pressure on the props, there's an art to how that all works. So as somebody is pouring, you have a poker or vibrator coming along behind it to ensure you don't get entrapment of air. So air pockets or honeycombing potentially down the line, that doesn't happen. So that's a big, I suppose, quality thing around that. We, as a manufacturer, we have our own quality app, so we do all our pre-pour checks. So the client can get, is the steel in the right place? Is this done? And then he can do it during the pour as well. So we have a full traceability quality, I suppose, form and app from that point of view. And then the big thing, I suppose, is on the other end of it. So from the concrete, you're doing the cube tests, you're getting the proper design mix, and you've traceability then with your cube tests at your 7 days, your 14 days, to ensure that, I suppose, the strengths are there. It's normally kind of around 30 Newton concrete. But the concrete actually forms very, very well within the ICF because it's a nice, consistent temperature, so it gets that strength nicely. And then where you have maybe dips in the temperature over, I suppose, the winter months and that kind of thing, it's less affected, which is nice. It keeps the strength in it.
Okay, and just on that, so is it a case that there is a specific mix for ICF builds as distinct from other concrete mixes, and then other like approved suppliers in terms of the concrete providers, or even from where the virgin cement comes from?
There's not a huge, I suppose, onus or I suppose issue that's going to certainly create additional costs from the concrete. It's essentially concrete that once it can go through the pump, that's the big part of it, that it can flow into the, I suppose, the or in around the rebar and that kind of thing. So 30 Newton concrete, as part of the NCI certification, it's a minimum of 25 Newton, 120 mil slub, 10 mil aggregate, typically is what's used. So there isn't any specific huge requirements around it, which is a good thing.
Okay, very good. Let me just go through. Okay, here's a very detailed one. I'll throw it out. For 5 stories, how are vertical ties for consequence a class 2B robustness detailing provided? Right, well, that's, I'd say, my wheelhouse, so if you can interpret that, Andrew.
So when we're doing 5 stories and around the reinforcements, we will have a 200 millimeter concrete core within the ICF itself. As I mentioned, there's a 150 and a 200. So with the 5 stories and maybe party walls within the 3 stories where you have bearing of various elements coming on precast, and that, you'll have the 200 core. So the 200 core does a lot of things. Obviously, it provides an additional strength in the concrete. You have a wider base there, but also the reinforcement. Generally, certainly at a 5-story, you'd have a lot more distribution steel going on. So you'd have a tighter steel reinforcement design within it. So as I said, up to your 3 stories, it's normally H12 at 1200 centers. When you're getting into the 4s and the 5 stories, you're seeing reduced spacing, so maybe up to 400 centers, bars at each face. You know, when you get into your OPEs, you'll have a design around maybe 4 bars to create a head with certain links and that kind of thing. So there'll obviously be a lot more distribution steel happening in those bigger builds. And again, these are all captured then the structural design team. We have a design guide there, I suppose, that we furnish to structural engineers as they're get their heads around ICF and how it works. From a standing standpoint, it's a plain unreinforced concrete design. As I said, when I get into 4 to 5 stories, it's a different thing. So we have a different design guide specifically for that. But you'd have a lot more distribution steel. Easy placement then within the bigger core of the ICF as well. Hopefully that answers it. I think you're gone there, Dick.
Hey, your speaker's gone, Dick. I don't know what's happened there.
It's gone very garbly.
I think that's covered pretty much all the questions anyway, Andrew.
Cool.
And
well, I mean, if anyone has any very specific questions or even general stuff, you know, just get in contact with me. My email is very, very simple. It's andrew@amvicireland.com, or obviously through yourself, Annie, if you want to send anything on to me, I'm happy to answer it.
Apologies, Anna. Am I still on?
You're back again.
oh, you're back. You're back.
Not sure. I'm in leagues at the minute, so maybe the signal's a bit dodgy when you cross the water. So that was one last question. I think it's merited there, Andrew. In terms of the market, obviously a lot of MMC providers, there's still an element of education across the main drivers, be it architects, even as from a funding point of view. Do you still see that in ICF in terms of, you know, people still in a traditional way of thinking, and that has issues in terms of everything from insurance and home bond, all the main factors that basically limit or will open up the market for you?
You're seeing more and more engagement from different I suppose sectors there. So certainly home bond, we've worked a lot with them over the last year or so, I suppose, in terms of detailing and what they're looking to see. So we've aligned a lot with them already. So that's a good thing. Insurance standpoint, we get every so often you'll get a curveball thrown at you where there's an insurer may have had a team of people looking after certain types of risks, and they change the teams, and somebody comes in and they've a few more queries, and you get a curveball where somebody doesn't quite understand it. But what we've done certainly over the last year or so, and we're working together as ICF manufacturers to I suppose create our association, and I suppose be a little more proactive from this point of view. We've engaged a lot with the insurers, so certainly myself have gone and spoken with insurance companies and helped them understand it, and they're a lot more comfortable once they get engagement, because it's like everything. If you're not used to it, like if you're looking at whether it be a builder's all risk or just insurance of a building. It's correcting the right kind of build type, so it's a solid wall construction at the end of the day, and that's it. So we're seeing I suppose less and less hurdles. That's the big thing.
Yeah, and I suppose that's the case for let's say most MMC providers and system providers. It's a bit out, and that's arguably the purpose of these lunch and learns to feed into that. Yeah, we've a lot of people here from the public sector, architects, people who are trying to learn about new systems when they come on their table, or they've been asked from by their clients. So, hopefully here's another wee nudge in that direction, Andrew. So listen, we'll pull things to a close before people start dropping off. We've held our audience quite well, so that's always a good sign for the content, Andrew. If it's not, people will doze off and go for an early lunch. So listen, on behalf of MMC Ireland, I'm going to introduce Anna here in a minute, just to update you on a few things that are coming up ahead over the next couple of weeks and months. But from my perspective, huge thanks, Andrew. Very informative. And we look forward to keeping an eye on Amvic and the wider ICF industry as it continues to grow. So I'll just hand you over to Anna, who's just going to update you on a few events coming up and the next Lunch and Learn.
Oh, thanks, Dick. Yes, I just wanted to point out that the next MMC Ireland Lunch and Learn will be with ecological building systems. So I put that in the chat, which I hope you can see. And also I'd like to bring your attention to our MMC Ireland Conference, which will be taking place at Johnstown Estate on the 5th of March. So do please reach out if you want to find out some more information on that. And then the day before, we've got a tour with Forte Pesper in the afternoon, so balcony manufacturer. So yeah, those are the updates. Thank you.
I think last I heard, tickets are going fast. So as I say, is there still an early bird, or is that just kind of gone on it? But maybe if you speak nicely, Dan, you might look after you if you give evidence that you're here today. But so keep an eye on that, folks. It proves to be a good day. We've had a change to the last couple of years, so again, continue to try and to add to the conversation. Other than that, we'll wish you all well. At this start, it's getting too late to wish people happy new year, but continued success into 2026, and we look forward to seeing you maybe at the next Lunch and Learn, or the conference, or some other trade show, which there are plenty of by the looks of things. So listen, thanks again, Andrew, and thank you all for tuning in. Bye now.